Good morning, all of you. Good morning, all of you. So, in the previous class, we discussed about fuzzy logic and topics regarding fuzzy propositions and inference rules for fuzzy propositions. And we also discussed about functional blocks of fuzzy information system or fuzzy inference system. Okay. Right? Okay. Next one is fuzzy inference system. So fuzzy inference system. So this particular fuzzy inference system, FIS, it is the key unit of fuzzy logic system. So that takes decision making. That means it takes decisions based on the situation present over there, right? So that particular system is known as fuzzy interference system, fuzzy inference system. So it uses fuzzy logic in order to take decisions, right? So it is the key unit of fuzzy logic system that takes decision making as its primary work. So the primary work of fuzzy inference system is to uh, take decisions, right? Right. So this is the key unit of fuzzy logic system, right? Next. So coming to the working of fuzzy inference system. So it uses if then. It uses if then logic or if then rules along with the connectors or and. Okay. So that means either or and operations are used for are used along with the if then rules. So if then rules along with that or and operations, right? So in order, so it uses if then rules, and also it uses the connectors like or and operations for drawing essential decision rules. So in order to take decisions, it uses if then rules, and also along with that it uses the connectors or and. Okay. So coming to the characteristics of fuzzy inference system. So these are the characteristics of fuzzy inference system. So the output from fuzzy inference system, the output from fuzzy inference system is always a fuzzy set irrespective of its input, which can be fuzzy or crisp. Okay, so whatever may be the input, so whether it is a fuzzy input or it is a crisp input, so the output will always be a fuzzy set. The output will be fuzzy set, right? Next, come to the second characteristic. It is necessary to have fuzzy output when it is used as a controller. So it is necessary to have fuzzy output when it is used as a controller. That means whenever we are using the fuzzy inference system as a controller, then you're definitely going to get the fuzzy output. Okay. Next one. Third characteristic is a defuzzification unit would be there with fuzzy inference system to convert the fuzzy variables into crisp variables. So in order to convert the fuzzy variables into crisp variables, so the fuzzification unit will be used. Okay, so this particular fuzzification unit in the fuzzy inference system converts the fuzzy variables into crisp variables. Right. Next, coming to the functional blocks of fuzzy inference system, the following are the functional blocks of fuzzy inference system. Following are the fuzzy functional blocks of fuzzy inference system. Okay, first one is rule base. First one is rule base. Second one is database. Third one, decision making unit. Fourth one, fuzzification interface unit. And next one, defuzzification interface unit. Okay. So coming to the first functional block, that is rule base. So this particular rule base contains fuzzy if then rules. So these are if then rules, right? That is rule base. Next one is database. Next one is database. So this particular database defines the membership functions of fuzzy sets using fuzzy rules. It defines the membership functions of fuzzy sets used in fuzzy rules. Okay, so it uses membership functions of fuzzy sets. Okay, so all the membership functions of fuzzy sets are used in fuzzy rules. Okay, so that is there in database. This all the fuzzy rules, all the fuzzy member functions, used in fuzzy rules will be present in database. It's all the rules. Okay, so all the membership functions are there in database, and rules are there in rule base. Okay, next one, decision making unit. So this particular decision making unit performs operations on rules. That means we have the rules. So those particular rules should be applied somewhere. So the operation on rules will be applied by decision making unit. So based on the rules that are there in the rule base, it is going to apply which rule is to be applied to which particular operation. So that will be performed by the decision making unit. Next one is fuzzification interface unit. Next one is fuzzification interface unit. So this particular fuzzification interface unit, FIU, converts the crisp quantities into fuzzy quantities. In order to convert the crisp quantity into fuzzy quantity, we use the fuzzification interface unit. Next one is defuzzification interface unit. So this particular DIU, that is defuzzification interface unit, converts the fuzzy quantities into crisp quantities. That means crisp to fuzzy by fuzzification, fuzzy to crisp by defuzzification. So the following is the block diagram for fuzzy inference system. So let's see this one. This is the this is the block diagram. So first one is fuzzification inference unit here, and in between. So first one is fuzzification inference unit. Next one is defuzzification inference unit. In between these two, we have the knowledge base and decision making unit. The knowledge base has two things. One is database, another one is rule base. Database, rule base. That means um, the crisp input will be taken by the fuzzy inference unit, and that particular fuzzy inference unit, it is all the rules that are to be applied, and uh, all the membership functions that are to be used in the fuzzy sets are there in the database and rule base. So those particular database, so it takes the membership functions and also the rules from the uh, knowledge base. Okay, from the knowledge base, it is going to take the so the fuzzy interface unit or fuzzy inference unit. Fuzzy inference unit is used to take the input from the user. Next, it is going to consider all the rules that are to be applied, and that also considers the membership functions. So it takes the membership functions from the database and rules from the rule base, and is going to give it the input along with these membership functions and rules to the decision making unit. So all the fuzzy, so that means that so this particular fuzzification interface unit converts the crisp quantities into fuzzy quantities. So see this one. So it takes the crisp input and it converts it into fuzzy input, and that the fuzzy input. So we will get this particular fuzzy input based on the, so by applying all the rules and also the membership function is going to get the fuzzy input. So that the fuzzy input is given as the input to decision making unit. So now the decision making unit will convert. So this particular decision making unit applies the rules or it performs the operations on rules, then we're going to get the fuzzy output. So this fuzzy output will be given to the defuzzification inference unit. So this particular the aim of this particular defuzzification inference unit is to convert the fuzzy output to crisp output. Now I'm going to get the crisp output as the output. Now let us see the working of fuzzy inference system. Coming to the working of fuzzy inference system, a fuzzification unit supports the application of numerous falsification methods. So a falsification unit supports the application of numerous falsification methods and converts the crisp input into fuzzy input. So in order to convert the crisp input into fuzzy input, the falsification unit is used. Okay. So in order to convert the crisp input to fuzzy input, the falsification unit supports various number of falsification methods. By using various number of falsification methods, it is going to the falsification unit is going to convert the crisp input into fuzzy input. Okay, by using numerous number of falsification methods. Right. Next one, knowledge base. Coming to the knowledge base is a collection of rule base. So it's a collection of rule base and database that is formed upon the conversion of crisp input to fuzzy input. Okay. So this particular knowledge base is a collection of rule base and database. Okay. So that is formed upon the conversion of crisp input into fuzzy input. Okay. So in order to convert the crisp input into fuzzy input, it takes the values or the methods from the knowledge base only. That is the falsification unit takes whatever it needs from the knowledge base. So this knowledge base is a combination of a collection of rule base and database. Okay. Next, coming to the defalsification unit. So the defalsification unit converts the fuzzy input into crisp output. This water fuzzy input we get from the decision making unit that will be converted to crisp output by the defalsification unit. Okay, right. So coming to the methods of fuzzy inference system methods. Coming to the methods of fuzzy inference system, there are two important methods in fuzzy inference system that have different consequent of fuzzy rules. Okay. Now let us see those two important methods in a fuzzy inference system. First one is Mamdani fuzzy inference system, and second one is Takagi Sugino fuzzy model. So these are the two important methods of fuzzy inference system. One is Mamdani fuzzy inference system. That is MFIS. Next one, Takagi Sugino fuzzy model. That is TS method. Okay. So MF method, MF method, and next one TS method. So coming to the first one, that is Mamdani fuzzy inference system. So this particular system was proposed in 1975 by Ibasim Mamdani. Okay, so he is the inventor of this particular inference system. This was proposed in 1975 by Ibasim Mamdani. So basically, it was anticipated to control a steam engine and boiler combination by synthesizing a set of fuzzy rules obtained from people working on the system. That means, in order to control a particular steam engine, so I can see the steam engine and boiler in industries. So in order to control this particular steam engine and boiler combination, so they're going to apply some set of fuzzy rules. Okay, so that means no person is involved there. Only the system is going to do everything. Okay, so this particular inference system is used to control a steam engine and boiler combination by synthesizing a set of fuzzy rules obtained from people working on the system. In the previous days, that particular thing was done by the people only. So this particular fuzzy inference system takes the input from the, it knows the how to do the process of combining the steam engine along with the boiler combination. అంటే ఏంటంటే స్టీమ్ ఇంజిన్ ని బాయిలర్ ని కంబైన్ చేసి సో అక్కడ ఏ విధంగా ప్రాసెస్ చేయాలి అనేది పీపుల్ నుంచి ఆ ఇన్పుట్ తీసుకుని ఆ ఇన్పుట్ ని అక్కడ ఫజీ సెట్స్ రూపంలో అక్కడ పెడతారు. ఓకేనా? సో అప్పుడు ఏం చేస్తుంది, సిస్టమ్ మొత్తంతో చేస్తుంది. అంటే ఏంటి, సో వితౌట్ ద హ్యూమన్ ఇన్వాల్వ్మెంట్ ఇట్ ఇస్ ది సిస్టమ్ ఇస్ గోయింగ్ టు డూ ఎవ్రీథింగ్ వితౌట్ ద హ్యూమన్ ఇన్వాల్వ్మెంట్. ఓకే, right. So it is used to control a steam engine and boiler combination by synthesizing a set of fuzzy rules obtained from people working on the system. Right. Next. So the following steps are needed to compute the output from the FIS. Okay. Now let us see what are the steps that are to be followed to compute the output. Okay. First one is set of fuzzy rules need to be determined in this step. ఏంటి ఏమేమి fuzzy rules అక్కడ వాడాలి. So set of fuzzy rules that are to be need to be determined in this step. First one is we have to identify what are the set of fuzzy rules that are to be implemented. Okay, first one, set of fuzzy rules. Next, second one is in this step, by using input numbership function, the input would be made fuzzy. And in the input number function use చేసి తీసుకునే input ని fuzzy input కింద కన్వర్ట్ చేయాలి. ఓకేనా. నెక్స్ట్ థర్డ్ వన్ ఇస్ now establish the rule strength. Now establish the rule strength by combining the fuzzified inputs according to fuzzy rules. అంటే ఏంటి వేరియస్ నెంబర్ ఆఫ్ fuzzy rules అప్లై చేసి సో మనం ఫజీఫైడ్ ఇన్పుట్స్ ని స్ట్రెంగ్తన్ చేయాలి. అంటే ఏంటి రకరకాల రూల్స్ అన్ని అప్లై చేయాలి. అప్లై చేసి స్ట్రెంగ్త్ కలిగిన ఫజీఫైడ్ ఇన్పుట్స్ ని తయారు చేయాలి. ఓకేనా. సో ఫజీఫైడ్ ఇన్పుట్స్ ని తీసుకుని సో మనం అప్లై చేసే ఆ రూల్స్ ఏవైతే ఉందో ఆ రూల్స్ యొక్క స్ట్రెంగ్త్ పెరిగేటట్టు చేయాలి. అంటే ఏంటి ఇది అప్లై చేస్తే ఖచ్చితంగా నాకు అవుట్పుట్ ఇలా వస్తుంది. అంటే ఏ రకమైన రూల్స్ వాడితే నాకు కరెక్ట్ అవుట్పుట్ వస్తుందో దాని ప్రకారం కావాల్సిన రూల్స్ ని యూజ్ చేసుకోవాలి. సో కావాల్సిన రూల్స్ ని తీసుకుని సో ఆ కావాల్సిన రూల్స్ మనం ఏం చేయాలంటే స్ట్రెంగ్తన్ చేయాలి. అంటే ఏంటి ఖచ్చితంగా ఈ రూల్స్ వాడితే నాకు అవుట్పుట్ ఇలా వస్తుంది అనుకున్న రూల్స్ అప్లై చేయాలి. ఓకేనా. సో నా ఎస్టాబ్లిష్ ద రూల్ స్ట్రెంగ్త్ బై కంబైనింగ్ ద ఫజిఫైడ్ ఇన్పుట్స్ అకార్డింగ్ టు ఫజీ రూల్స్. అంటే ఫజీ రూల్స్ ని బేస్ చేసుకుని ఫజిఫైడ్ ఇన్పుట్స్ ని స్ట్రెంగ్తన్ చేయాలి. ఓకేనా. నెక్స్ట్ ఫోర్త్ స్టెప్. ఇన్ దిస్ స్టెప్ determine the consequent of rule by combining the rule strength and the output numbership function. So by combining the rule strength and the output numbership function, we have to determine the consequent of rule. అంటే ఏంటి ఈ రూల్ అప్లై చేస్తే ఇలా వస్తుంది అని దానికోసం ఏం చేయాలి అంటే రూల్ స్ట్రెంగ్త్ ని అట్లాగే అవుట్పుట్ మెంబర్షిప్ ఫంక్షన్ ని రెండింటిని కూడా కంబైన్ చేయాలి. దెన్ ఐ గోట్ టు గెట్ ద కాన్సిక్వెంట్ ఆఫ్ రూల్. ఓకే. నెక్స్ట్ after getting it for getting output distribution getting output distribution combine all the consequence. అంటే ఏమైతే అంటే రూల్ స్ట్రెంగ్త్ ని అవుట్పుట్ మెంబర్షిప్ ఫంక్షన్ ని కంబైన్ చేస్తే ఏ కాన్సిక్వెంట్ ఆఫ్ రూల్ వస్తుందో అలాగే అన్ని కాన్సిక్వెంట్ ఆఫ్ రూల్స్ ని తీసుకుని ఓకే అని కంబైన్ చేస్తే మనకు వచ్చేది అంటే అవుట్పుట్ డిస్ట్రిబ్యూషన్ వస్తుంది. సో ఐ గోట్ గెట్ ద అవుట్పుట్ డిస్ట్రిబ్యూషన్. సో ఫైనల్లీ డీఫజిఫైడ్ అవుట్పుట్ డిస్ట్రిబ్యూషన్ అప్డేట్. ఓకే. సో ఏ అవుట్పుట్ డిస్ట్రిబ్యూషన్ అయితే మనకు వచ్చిందో దాన్ని డీఫజిఫికేషన్ ప్లస్ యూనిట్ ఇస్తే దెన్ ఐ గోట్ గెట్ ద డీఫజిఫైడ్ అవుట్పుట్ distribution. Okay. So this is regarding Mamdani fuzzy system. Right. So this is how you get the output. Right? So by applying if rules, you're going to get the rule strength. That is, the rule strength should be improved, and then this particular output will be replaced. Okay, the input distributions and the output distribution. Okay, that's it. So this is how to perform the Mamdani fuzzy inference system. Next one. Next one is Takagi-Sugino fuzzy model, that is TS method. So this particular model proposed by Takagi. So this particular model was proposed by Takagi, Sugino and Kang in 1985. So this particular TS method was proposed by Takagi, Sugino and Kang in 1985. And the format of this particular rule is given as if x is a and y is b, then z equal to f of x comma y. So this is the rule, right? If x is a and y is b, x equal to a and y equal to b, then z equals to f of x comma y. Right. Now see this one. AB are fuzzy sets in AB, A and B. So AB are fuzzy sets in the antecedents, and z equal to f of x y is a crisp function in the consequent. So f of x is a crisp function, and AB are fuzzy sets in antecedents. Now, the fuzzy inference process under Takagi-Sugino fuzzy model works in the following way. Now, let us see how this particular TS method works. First one, you have to fuzzify the inputs. Next, you have to apply the fuzzy operator. These are the two things to be done, right? So, fuzzifying the inputs means here the inputs of the system are made fuzzy. So, all the inputs that we use in the system are made fuzzy. Next one is you have to apply the fuzzy operator. So by applying the fuzzy operators, you'll get the output here. Okay, first one is fuzzifying the inputs. Second one is applying the fuzzy operator. These two things are to be done in TS method: fuzzifying the inputs and applying the fuzzy operator. Next, now if we compare these two methods, the comparison between the Mamdani system and the Sugino model is these three things. So we can observe these things. First one is output membership function, and next one is aggregation and defalsification procedure. Third one is mathematical rules, and fourth one is adjustable parameters. So these are the four things we can observe between these two. Right? First one, output membership function. The main difference between the output membership function in both the methods are on the basis of output membership function. Okay, so this is the main difference between the two methods. Okay, the Sugino output membership functions are either linear or constant. Okay, so so here the output membership function in TS method is linear or constant. Okay, and next one is aggregation and defuzzification procedure. So the difference between them also lies in the consequence of fuzzy rules, and it is the same. The aggregation and defuzzification procedure also differs. That means there is some difference between the aggregation and defuzzification procedure in both the methods. And third one is mathematical rules. Okay, so more mathematical rules exist for the Sugino rule than the Mamdani rule. Okay, next one is adjustable parameters. So the Sugino controller has more adjustable parameters than the Mamdani controller. So these are some of the comparisons or the differences between the two methods. Okay. Now let me see how many have attended my class. Only 55 today. I don't know why the attendance is being decreased day by day. So this I'm stopping my class today. We'll discuss the remaining topics in the next class. Okay.